Bismillahirrahmanirrahim. We'll just talk about the few slides left from chapter 3. So we started talking about the peer-to-peer, and we said that this is a new paradigm which is different from client-server model. So here the devices can act as client and or server at the same time. Any peer, any device can initiate the communication, and the files or the content is actually hosted on any device. So if you just start the peer-to-peer application on your machine will work as client and server at the same time. It's not your choice in that case. So your content is going to be shared. At least some content you have to share. So so these end devices can then act as client and server, and there are so many examples for this software, the peer-to-peer applications like Napster, like eDonkey, eMule, or BitTorrent, and many other peer-to-peer applications that use that paradigm. As we discussed last time, the problem now is that there's no single host or there's no single server that hosts the content, which means that the content is actually distributed all over the earth. So the problem now is that on one hand, you cannot get your hand on where the content is, so you cannot have any control. On the other side, how do peers find this content? That's the issue that we need to discuss now. So the peer-to-peer file sharing accounts for more traffic on the internet than any other application. The reason is that if you leave the control to individuals, you will end up with huge amount of data. So if you have like servers they tend to have limited number. So there are few servers that can host content. Therefore, you can easily have control over these servers. But when we talk about peer-to-peer, any individual at home may have 2 or 3 devices running peer-to-peer applications. He or she can host this content, some content here, some content there. So there's no way for you to control this content. So there is no centralized file server in that case. For example, if you connect to one peer looking for a file, and this peer or this device tends to have a corrupted file, you go with the next one. If the server has any problem, this is always the problem with centralized models. If the server has a problem, all the clients are doomed. They cannot do anything. But here for peer-to-peer, it's distributed. So there is an advantage in the sense that there is no centralized node. If it fails, everything fails. No, here peers, they can wander through the internet and they can find the content of this file either on this device or that device or that device. So you have unlimited choices on the internet. And actually many of the peer-to-peer applications, they are smart enough to detect that the file is actually hosted on multiple devices, in which case they can connect to all these devices all at once and download the content of the file simultaneously from 10 different devices at the same time. So this way you can make the download much faster. So you're not dependent on one single centralized server in that case. You can make the connection through multiple devices at the same time.
How do peers choose each other?
They don't. Yeah, I will discuss that. In a way, you don't care that you connect to a particular peer. You just need to, you're just looking for a file, basically, or you're just looking for some content. Whoever has this content, you need to download it from them. But you don't care about the person himself, right? So we'll talk about the approach to do that.
Let's say I'm downloading from Cedars. They're called Cedars, right?
The Cedars?
Yeah, like...
Whatever. Yeah.
So it's like multiple. You said up to 10. Or
No, not up to 10. I'm not saying up to 10. It could be hundreds. I'm just making a number.
Different segments from each?
Right. Yes. Yes. Yeah. So you download the same file from different locations. You download the first part from this device, second part from that device, and you are making 10 different or 100 different connections to 100 different devices downloading the same file. So these types of applications, some of them at least, they are smart enough to do that. That requires a very complicated protocol, though. It's not easy. So what happens if one part fails? What do I do? So the application level protocol will be much more complicated, and for one single file you need to maintain now 10 or 20 or 100 sessions concurrently. That's complicated. So managing all these sessions or all these connections is not easy. Many of these software, as we said, the predominant application level protocol, which is HTTP, is being actually used more and more by different applications because of the fact that it is very simple, lightweight, it's text-based, and it seems to be scalable across distributed systems. So these softwares, they tend to have like HTTP request and response. So you can call or you can request a particular device, give me the content of this file, and then the response answers back that okay, 200 okay, and then this is the content. Similar to downloading an HTML web page. There's no difference. So HTTP is being used very widely in these types of applications. So the question now is, how do we find a particular file? So normally what happens is that you start your peer-to-peer application and you are searching for a file. When you are searching for a file, now we're not connected to a particular centralized server. If we are connected to one server, then we know that if the file does not exist on this server, that's it. We cannot do anything. We're done. But now, we don't know. We don't know where the file is. Okay? So how do we do that? Well, one approach is to say, I'm a peer-to-peer application, and there are millions of these peers on the internet. Whoever is starting their software on the host, they are peers. So now I want to search for a particular file. So one approach is to say, broadcast to who? I don't even know them. So one approach is to say, when they start, they will at least do some broadcast to say that we are there. So assume that we know about their existence. Okay? So we know that this one exists and this one exists and so on. But we have millions of them. Right? So now I'm searching for one file. So what do we do? So we need to have a call for each individual peer and look sequentially whether this one has the file, no, this one has the file, no, this one has the file, no, and so on. So that's not scalable, of course. So we're doing like some sequential search. Okay, So what is the other choice? Okay, so when another choice is that when these peers start, they should broadcast to all other peers, okay, the content of their files. Of course, that's also not scalable because, I mean, it doesn't make any sense that they broadcast the whole content. Okay, so let's say they don't broadcast the content, they just broadcast the names of the files. So just identification of the files, not the actual content. Okay, so that seems to be more logical, but again, should we broadcast it to all peers? So the answer is no. What happens is that even though we're just saying that this is peer-to-peer and no centralized server, the fact of the matter is there is actually a centralized server. So it's not fully distributed. What happens is that we have a centralized directory server, not file server. The directory server here, what happens is that when you start the peer-to-peer application, this peer-to-peer application needs to connect to a centralized server. This centralized server contains not the content. That's the main difference. It contains only the information about this content and where they exist. Okay? So the centralized directory server here maintains two pieces of information. What is the identification of this content or the file, and where do they exist? Okay? So by doing that, we allow all these peers to know where the content exists. So we just need to connect to one server and search for that file. And in order to make this even more scalable, because as the content start to get very huge, even the names become a lot. Even the names of the file become a lot. So the difference here is that this is much more scalable compared to client and server. Why? Because here we're not maintaining the content itself. We're just maintaining where the content exists. So that's much more scalable than client and server. If we want to make it even more scalable, create multiple of these servers. Okay? So in that case, the peer, when it starts, it can connect to 1 or 2 or 3 or 4. Okay? It can connect to them sequentially or concurrently. Okay? But now it's much more scalable and feasible. Scalable from the sense that we can maintain a huge amount of file names and where they exist. And on the other side, it's feasible for peers to connect to 1 or 2 or 3 servers rather than just doing some sequential search on millions of peers to find where the file is, which does not make any sense. So now I'm connecting to maybe 1 or 2 or 3 servers, maybe 10 servers at most. And then these servers will contain information about where the content exists. Once we do that, we search for the file. If we find the file, we will find the file name and the IP address of the peer that contains that file. Okay? So the first call is to search where the file is. We connect to the server. If we find the file, then we find next to it the IP address of the actual device that hosts that file. So the next step is to just connect directly to that file, to that device, to download the actual content. Okay? So we are actually splitting now the two steps compared to client and server. Client server model, we do the 2 steps on the server, right? We search the file on the server and we download the file from that server. Here, what we do is that we search the file name and location on the directory server. If we find that file, we find next to it the IP address of the device. So the next step is to connect directly to that device. So this way we are increasing the scalability by big amount, by order of magnitude. Why? Because this directory server can contain the names of billions of files. So it can have small database to contain the names of the files easily. Using gigabyte, using 1 gigabyte or 2 gigabyte, you can contain the names of millions and millions of files. And next to each file, there is an IP address or multiple IP addresses. So if you fetch the file name and you find multiple IP addresses, some software, they take the first one and they connect to it, that's it. And some intelligent applications, they connect to all these IP addresses concurrently. So you find yourself connected to either one device or maybe multiple of them concurrently to try to speed up the download time.
Can be like the closest here.
That's part of it. That's a very good point. This is part of it because sometimes I may connect to multiple of these peers and some of them are very far. So that limits the download time. So the location, that's a very good point. The location and the proximity of these peers is another issue. That's why BitTorrent is fast, because it actually tries to optimize the speed of the download by detecting the distance or the location. What is the probability that these 2 or 3 or 5 peers, they exist close to each other? Okay, so you don't have to worry about that. The application does that for you. But in order to do this efficiently, it has to have some intelligence. Okay, so so the problems about a directory server now is the same problem for client and server, right? So this first step is a prerequisite for us to do the second step. The first step to find the file on the directory server is a prerequisite to the second step. If we don't know where the file is, we cannot download it. So again, we came back to the single point of failure. Okay? So if we cannot find where the file is, we cannot download it. So that's the problem, but we have no way around it. So in order to maybe enhance this a little bit, we can have multiple directories. So sometimes, if some of you have tried some of these applications, you connect to some servers, it says that the server is down, and you try to connect to another one, and it connects. And they don't have to have the actual or the identical database of files. Okay? So you can find a file on one server but not the other. There might be some overlap, but that doesn't mean that they are identical. But at least this gives you some diversity in the sense that if you don't find this server up and running, you can connect to another server. Okay? So at least this way you are increasing the probability that you can find your file on one of the servers. Okay? So we'll stop here. Next time, inshallah, we'll start chapter